speaker is Stephen Newton, who is the Director of Business Development for Discovery Air Innovations. As he will tell you, very well-established aviation going concern in Canada, and one that has got the foresight and the courage to launch into a very new field of hybrid air vehicles, or what many of us might think of as being buoyant vehicles or airships. Stephen has 28 years in the Canadian military in his background, training people in seeking helicopters. Navigation, I understand, was your forte. After that, he spent some time working with the unmanned aerial systems, early into that field, and since 2010 has been involved with Discovery Air and on this project. So without further ado, Stephen, I'll turn it over to you.
Thanks, Brian. So very quickly, Discovery Air, 4 divisions. Northern Services. Discovery Air is based out of Yellowknife, Northwest Territories. We've got 4 divisions. Northern Services, which is Great Slave Helicopters, Air Tindy, and Discovery Mining Services, all based up in Yellowknife, bases across Canada. Government Services, Hicks and Lawrence, Walston Air, Discovery Air Fire Services, Discovery Air Aviation Academy, and Top Aces. Provide support to the government, for both provincial and federal. Technical services based in Quebec City and Toronto, do all the engineering work. And then the smallest group, which is my group, Discovery Air Innovation, it's about 15 people, bases in Calgary and Montreal. And we do the future look. So we're, if you like, an outside the box type group. We're looking at new areas, new technologies, and about 5, 10, 15, 20 years out. And our job is to shape the company to take advantage of that new technology. So, very quickly, I'm here to talk about hybrid air vehicles. Hybrid air vehicles are not a blimp. It's not an airship. So, why is Discovery Air doing hybrid air vehicles? The U.S. Senate Armed Service Committee noted that the U.S. services have spent over $1 billion in lighter-than-air technology this year. $517 million on the LEM-V, more than $60 million on the HE, on the Blue Devil. There's a couple of other portfolios, and then a number of aerostats that are currently in Afghanistan as protection to forward operating bases on a fixed surveillance platform. So the U.S. Senate Armed Service Committee said, look, you're spending $1 billion on this. I want someone in charge. The last time this occurred in the U.S. military was in 1998, when I was introducing UAVs to the Canadian Forces. At that time, in 1998, there were 6 UAVs, 6 systems in service. As of last week in Afghanistan, there's more than 8,000 UAVs flying. This is going to happen. It's part of the future. In Canada, our Defence Research Establishment have concluded that they present a substantial savings for operations in the Arctic, savings of up to 60% in cost avoidance. That means you don't have to build roads, you don't have to build infrastructure, you don't have to build airports. So, for Discovery Air, this technology is seriously going to impact Canadian aerospace technology in the next 5 to 10 years. Canada's Arctic is going to be the focal point for operations. That's our background. So we will operate a fleet of hybrid air vehicles, and we will introduce them to commercial service by 2015. So here's how it works. 3 types of lift. The obvious lift, aerodynamic lift, which is the helium. And on our 50-ton, there's about 85,000, 90,000 cubic meters of helium inside that bag. The vector thrust, there's 4 aircraft turbine engines on board, 2 PT-6s on the front, 1 27s on the rear. That gives us plus or minus 25% vector thrust. Plus 25% pushes us off the ground, minus 25 holds us down on the ground. pushes us down out of the air or slows us down. Buoyance lift, 60% of the lift from the helium. Sorry, the aerodynamic lift is from the air moving over that wing shape as we move forward. Now the other advantage that Roger Monk came up with is this hovercraft landing system. The hovercraft landing system, you see an image of it in a second, is like landing gear. As we're on final approach, the hovercraft landing gear comes down, and it provides a cushion of air for the aircraft to ride on. Maximum gross takeoff weight is about 200,000 pounds. With the hovercraft landing gear, the actual pounds per square foot on the ground is less than you or I. It's about 46 pounds per square foot on the ground. So that allows us to land on water, snow, ice, and a relatively flat surface. Relative roughness being about 2 feet. So we can land on obstacles that are about 2 feet high, and we'll just roll across them. The airflow within those hovercraft can then be reversed. So once we're in position, say we're going down to Haiti, say there's another earthquake in Haiti, the ports are destroyed, the airfields are destroyed, we're going to fly the disaster response team down, everything in, we're down, we can land right in the harbor, spin around, back up to the beach, drop the ramp down, and deploy the troops. You don't need the infrastructure. When you're in position on the ground, you can just reverse the flow within the hovercraft. It's not a lot of pressure. Excuse me. It's only about 2 inches of water, which is not a lot, but it's over such a wide area, such a large area, that it actually serves as brakes. So that means that we can load and unload, and we don't need those 100 people that are running around with ropes to hold it all down. We can unload in winds up to 35 knots. Relative sizes, the orange arrow, 17,000 cubic feet, 50 tons, 5,000 kilometer range, speed 84, 85 knots cruise, 104 knots dash. There is a 200-ton version with 65,000 cubic feet. The plan is right now to introduce that about 5 years after we introduce the 50-ton. So, logistics. The traditional logistics system across the top creates all sorts of problems. The United Nations World Food Program loses 25% of its supplies between the warehouse in Brindisi and the refugee camp in the Sudan. Fresh fruit and flour companies operating out of Brazil, shipping to North America and to Europe, lose between 25 and 40% of the weight of their shipped produce. That's because they have to put it in a refrigerated container, put it on a truck, put it on a ship, get it across, move it up. If they're flying it up, then it makes sense, and the losses go down. Carbon footprint, large footprint, 747-400 and a C-17 burn 12 tons of fuel an hour. The 50-ton hybrid air vehicle will carry 50 tons, 5,000 kilometers, and consume 12 tons of fuel. So if you're in the Arctic, you got another problem. You don't even have that transportation system. So with the hybrid air vehicle, we're going to change that logistics system. And this is where the paradigm shift occurs. And this is what most of the people in this room will have the hardest problem with, is that we're going to change the way we have grown up moving stuff